we've made it to the last section. This is the section on coding the volleyball itself, which is honestly the funnest part. Now we actually get to play this game. So let's just get into it. There will be a few different ways that we can interact with the volleyball, and the very first one is that it should just be able to bounce off of both you and the opponent, right? Like if a volleyball hits you in the face, it should be able to bounce off away from you. So we're going to start with that one, the easy one. So go ahead and open up the volleyball script itself. I'm going to remove some of the earlier comments so that the code is a little bit smaller. So far all we have is an out of bounds feature. So now we need to add collision detection, right? So there's methods for that. There's on trigger enter, which is usually for like pass through collisions, like when you collect coins, but there's actually on collision enter, which is used for hard surface collisions. So we're going to create a new method above the last bracket. It's going to be void on collision enter. And this is called when two objects collide, and it returns a collision, and I'm just going to call it other. So it's going to store the collision data of the thing that we hit. So the ball needs to figure out, hey, did I just hit the player or did I just hit the opponent? So we're going to check if the other game object's tag is == player, then we know we've hit the player. And if the other game object's tag is opponent, then we know we've hit the opponent. And let's save and double check real quick. Just making sure the player over here, yep, is tagged player. The opponent is tagged opponent. Back opponent is opponent. Cool. So when it bounces off of us, we do want to have just a little bit of wiggle room, like a little bit of a randomness on the x-axis. So it could bounce off of me a little bit towards the left or a little bit towards the right, just like a skosh. So I'm going to create a float called x, and that's going to equal a random amount, so random.range between negative, I don't know, 0.05 and positive 0.05. And this we should also do for the opponent. So I'm going to copy that and paste that down there. And now we get to calculate the new velocity that the ball should be going and apply that to the rigid body, right? So calculate new velocity, apply to rigid body. Velocity usually takes in 3 variables, an x, y, and a z. So we know that for the x, it's going to be the direction, right, should be from where we are minus where the opponent or the player is, whatever I've hit. So like my transform minus the other transform, and then we're going to add in that x variable, that randomness. Otherwise, without the x, it's just going to be a straight bounce. This makes it a little more interesting. For the y value, we want that to go up, right? Assuming this is volleyball and we're trying to hit things up. Again, it's kind of like volleyball. It's not perfect. So I'm just going to say it's going to go up like 30. And then for the z, we're going to do the same thing that we did for the x, right? Is we're going to say my transform minus the other. So when, here, look at the ball and look at its z coordinates. So when the opponent's hitting it towards me, look what happens to the z. It's going more negative. When I hit it towards the opponent, it's going more positive. It's getting bigger and bigger and bigger. So in the ball script, for the z calculation for the player, it's getting bigger. So for the z, we want to add something, I don't know, like 25 to the z. All right, this was kind of a lot, but here, let's just build it together. So it's a vector 3, and I'm going to call it velocity. And that's going to equal a new vector 3. For the x, we're taking in my transform.position.x minus the thing we hit, other.transform.position.x. And I'm going to wrap this little minus, this little calculation, in a subset of parentheses so that we can add that to the x, random x that we just made here, and then type a comma. Now we're in the y value, which is 30. It's going to go up. And then the z value is the same kind of thing we just did, transform.position.z minus the other.transform.position.z. And then we're going to sort of add 25 to that. So it's going back towards the other side of the court. Now that we have that, let's apply that to the rigid body. So I'm going to say rigid body.add force, and we're going to pass in the velocity. We can also create a speed if we want to for our ball, like an overall speed. I'm going to make that up at the top, a private float speed, and I'm going to set that equal to 10.0f. So we can multiply our velocity by that speed, so however fast our ball is. And then we can also factor in the mode of force. So I'm going to do force mode.force. You can try force mode.impulse and see kind of what the difference is. Force mode.force kind of of works for this application. Now let's do the same thing for the opponent so they can actually bounce it back to us. So we're going to calculate a vector 3 velocity, and that's going to equal a new vector 3. For the x position, we're going to once again take our transform dot position dot x minus the thing that we hit, other dot transform position dot x, and we're going to wrap those in parentheses real quick, parentheses, add that to our random x that we made, and now for the y, it's going to be like 30, and for z, we're going to say transform dot position dot z minus the other dot transform dot position dot z, and then for us, when we push the ball to the opponent, right, when it hits the player, it's going positive 25, but when it's hitting the opponent, it needs to go negative 25. Let's see if my parentheses are right. Okay, minus 25. Okay, here I'm going to zoom out. Kind of long, but that's what that vector 3 looks like. Now let's do the last thing as well, and let's apply that force. So we're going to say rb.add force. It's going to be our velocity times the speed at force mode dot force. Okay, let's see how this goes. Ooh, okay. And it kind of came right at me. Okay, a little bit hard to see. Oh, he also went through the wall. Cool. Opponent's on my side now. Loving that for me. Okay, we'll have to restrict where the enemy goes. But this is kind of working. Let's see. Can he hit it towards me? He can, kind of. There it goes. Perfect, and now it's on my side. I do need to make it so that he can't come over to the other side. Okay, so I just did it the kind of ugly way where I took my floor and I moved it over a little bit, and then on the opponent's floor, I just hit clear and rebake, and now there's like a little gap. So hopefully when he hits the ball to me, he won't go through to the other side. Let's see. Can he go past? He can't go past. Beautiful. All right. And can I hit it to him? I'm not really good at, okay, I can kick it to him like soccer. So let's take a look at the next feature, which is actually adding points when the ball hits either of our floors. Now we tagged the player floor as player floor. The opponent floors are also tagged as opponent floor. So if the ball touches either of those, it will know which floor it's hit. So down here in our ball script, in the on collision enter method, we're going to do two more methods. So if the game object that we hit is tagged as player floor, double equal sign, and if the thing that we hit equals the opponent floor. Now, if we want to change the color of the floor when we get a point, we need to grab a handle to the mesh renderer. So I'm going to say mesh renderer, I'm just going to call it ren, and that equals the other dot game object dot get component, and we're looking for the mesh renderer. Let's do the same thing. I'm just going to copy that and paste that into the opponent floor one, and then we need a method that we can call that will change the color for it, maybe for like half a second. So let's create a private IE numerator since we're dealing with waiting a second, and I'm just going to call it like change color and go back routine. Now this is upset because it doesn't have a yield statement, but first let's add in a couple parameters. We need to know what mesh renderer we're changing, like which floor we hit. I'll call that ren, and then we need to know what color we're changing it to. Color. So let's say the ren.material.color equals color. So that way you can say when I hit the opponent floor, turn green, versus when the ball hits the player's floor, turn red. And then let's yield return a new, wait 4 seconds, and I'm just going to wait like 0.5 f, and then the renderer.material.color will go back to normal, which for me is color.white, but you can choose whatever the normal color of your floor is here. And then let's just call that coroutine. Let's say start coroutine, change color and go back routine, and we are passing in renderer, and then what color do we want the floor to be when the ball hits the player floor? I want it to be color.red because it's bad. I'm losing a point. And then let's start coroutine, change color and go back routine. We're going to pass in renderer, and then the color we want when the ball hits the opponent floor is color.green, since that's a good thing. We just gained a point. And lastly, let's actually add those points. So we're going to say UI manager dot, what was the method called? Look at this. Update your score and update their score. So UI manager dot instance dot update. So when it hits the player's floor, it's their score. Yep. And then UI manager dot instance dot update your score. Okie dokie. Let's see. Let's go ahead and save our script and let's see if we can get points and if the floor changes color. Okay, I'm gonna let them score. Okay, it's red. Okay, I don't think I can actually really hit it back at them. I'm losing a lot of points. We need to have a better way to interact with this ball other than just slamming into it with our horrible little bean body. I'm going to cheat and move the ball. Okay, there. Okay, cool. And when it hits, wait, their score is 19-20. Oh, something is wrong here. My score became their score. So there's some weird assigned variable. So let's look in Canvas real quick. Player score, opponent score. They're assigned correctly. Let's look in UI Manager. Oh, look. Okay, so your score, their score, and your score. So these are mixed up. So your and your, this matches, but update their score, this does not. So we'll say their score, text, not text. Okay, now it should be working. They're getting points now. Yay. Okay, great. Now it's working. Oh, and I actually was able to hit it back to them. That is exactly what we want to see. The next feature is we want to be able to left click our mouse to like play Keepy Uppy with the ball. It's just going to be click to stay up. Let's go to our ball script. And it makes sense real quick, get rid of this, that we're going to want a reference to the player at all times, pretty much. So I'm going to make a serialized field, and let's just say it's a private game object, and we're going to call it _player. Save this and hop back into Unity. And on the ball itself, there, it's looking for a player, so I'm just going to drag player in. Now, in update, let's create our first input check here. So we're going to say if input.getMouseButton down, and we're going to do 0. 0 is for left click, 1 is for right click, and I think 2 is for the scroll wheel. And then in here, let's make a method that we'll call, let's call it like void try hit the ball. So inside this mouse button down, we're just going to call that method try hit ball. Right, we'll see if we're close enough. Can we hit it? Okay, so in try hit ball, we need to know what our power is. So eventually we will have a different amount of power based on how close we are to the ball. So once more down here, I'm going to make a little space. We're going to make a private method that will be a return type method. So it's going to be a private float, and I'll call it like get power. Eventually this will be based on how close we are to the ball, but for now we're going to return like 10. In try hit ball, we are going to create a temporary variable called power, and we're going to set that equal to get power. So power will equal 10. So we'll have a power of 10, infinite reach, infinite power for right now. And then as long as our power is greater than 0, which it will be forever since we always have 10, we're going to say rigid body dot velocity equals something, some kind of method that goes here. So let's create the method of keeping our ball up. I'm going to do that right here. Let's make a private vector3. Since we're setting our velocity to something, velocity needs an XYZ. So we're going to make that a return type method that's a vector3. And I'm going to call it like Keepy Uppy ball. Sure. And over here, I'm going to do this. Rigid body velocity equals Keepy Uppy ball times power. Whew. Okay. So now it's up to us to fill in what does it mean to do Keepy Uppy ball. Okay. So step 1 is the ball vector, which is from the direction that we're looking towards the ball, it's that line there. So it's the player's position minus our position as the ball. Player position minus ball's position. So we can create this as a vector3 ball vector, and that's going to equal the player.transform.position minus our transform.position. Okay, next up we need a thing called a plane tangent. So it's going to start to factor in where we're looking, not just where our human body is, but where the camera is actually looking. So I'll draw a little diagram here. Those two vectors coming out, this one being the ball vector, this one being the way that our camera is looking, and the cross product of those two is the plane tangent. So let's create that real quick. We're going to say vector3 plane tangent, and that's going to equal a cross. So there's a method for that, vector3.cross, and it's going to take in the ball vector and where our camera's looking, camera.main.transform.forward. Okay, so now that we have the cross product of those two, that's still not the right direction that we want the volleyball to bounce off in. So the next thing that we want to get is the plane normal, right? So we have this plane tangent that's sort of coming out of the screen. But but now we want to figure out the normal of this plane and then reflect that so it's going in the direction that we want the ball to go. So we're going to really quickly create a vector 3 plane normal, and that's going to equal yet another cross of vector 3 cross between the tangent that we just found, plane tangent, and the vector of the ball, the original line. Lastly, now that we have this plane normal, we can finally reflect that off of where we're looking and return that reflected vector. So we're going to say vector 3 reflected, and that's going to equal vector 3 dot reflect. And what we want to reflect is where we're looking and the plane normal. So camera dot main dot transform dot forward, and then plane normal. Finally, now that we have reflected, we can return the reflected dot normalize. So whatever this vector is, it's going to normalize it, so like shorten it to a magnitude of 1, right? So this is some value, some vector 3, where each xyz is between 0 and 1, somewhere in there, and those will all be multiplied by power, which is 10. I'm going to bring the ball to my side of the net, and I do have infinite reach, so I'm clicking the mouse and it's able to continue to be reflected up. There we go. It's a little bit weird, and it's a little bit weird to get used to this kind of movement. Like, in order to hit it over the fence, I have to kind of approach it from the side. If I want it on my side, that's also kind of hard to do. There we go. So I'm clicking it sort of from the side so it goes over there. Yeah, like easily. Just keep getting points. Okay, so that's honestly the hardest part of this program done. Now that we have this kind of Keepy Uppy script, we're just gonna riff on that in a bunch of different ways. For the next one, we're gonna make it, let's say if we right-click the mouse button, we're gonna tap the ball forward. Based off of what we just learned about this Keepy Uppy ball, let's try that. So I'm gonna make another if check here and update. We're gonna say if input.get mouse button down, and we're looking for number 1, which is our right click. And instead of try hit ball, let's make a new method, void try tap ball. We'll do another float power, and that's going to equal get power. And then if the power is greater than 0, we will set our rigid body's velocity equal to some method that we haven't made yet, which I'm going to make that method down here, and I'm going to call it a private vector 3 method, and it's going to be like tap ball up and forward, something like that. So this RB velocity here in try tap ball is going to equal tap ball up and forward times power. Okie dokie. Now it's time to riff on this that we just kind of messed with in order to reflect our ball around and try to make it go forward instead. So let's say we still want the ball vector. That makes sense. We still want to know where we are physically to where the ball is. And then honestly from here, what if we just reflect it? Like if we reflect this ball vector between me and the ball and we reflect it off of where our camera is looking. Let's make a vector 3 reflected, and that's going to equal vector 3 dot reflect. And let's reflect the ball vector and then the normal, which would be our camera dot main dot transform dot forward. Cool. And now let's make sure, like I said, that the Y position is always positive. So we're going to last vector 3 is like up reflect, and that's going to equal a new vector 3. So the first part is reflected, the thing that we just calculated, that thing, dot X. The X can stay the same. The Y should be the absolute value, right? So if you know what absolute value is, it takes whatever number that is and makes it positive. So if it's negative 30, it's now positive 30. So we're going to pass through the math function dot ABS. We're passing through reflected.y. Lastly, reflected.z. And we can return the upreflect.normalized. Oh, and then up here, make sure to have try tap ball. Okay, let's save the script and see if we can't right click to tap the ball forward. There we go. Right click, and I'm sending it honestly forward into outer space because I have infinite reach. There it goes. Goodbye, volleyball. Perfect. Tapping it forward totally works. We need to make sure we don't have infinite reach pretty soon because this is a little ridiculous. All right, I'm not sure what key to press for this, but maybe if you're tapping it and shift is pressed, then we will spike the ball. If you're not pressing shift and you right click, then you'll tap the ball, right? Because those actions are kind of similar. So within this get mouse button down, we're gonna check if input.getKey, so it's if you're holding it down, and we're gonna say keycode.left shift. Then we're gonna try spike ball, and then else, meaning you've right clicked but you're not holding shift, you will try to tap the ball. Cool. Okay, so let's try spike ball. So now I'm gonna go down here below try tap ball. Let's make a void try spike ball. I hope you're seeing a pattern here. This try spike ball, we're gonna do this very similar stuff. Float power equals get power. We are gonna check if the power is greater than 0, and then we're gonna say the rigid body dot velocity equals a method we haven't made yet, which is going to be down here, private vector 3 try, or maybe spike ball. There we go. So now let's finish out this method, spike ball times power. And up here in our input check, we're going to say try spike ball. Okay, now we can scroll down and we can fill in the vector 3 part and see if we can't figure out from all of this stuff that we've been messing with, can we make the ball spike downward? And I think in order to spike the ball down, you know how we did the ball vector and we reflected it, but we made sure that it only went up so that the Y was up? What if we just don't up reflect it? Like literally, what if we take these two lines, paste them into here, and then over here, we're just gonna return reflected dot normalized. Let's see if that works. Okay, shift click and it's going down. Shift click, shift right click. I mean, it's kind of working. The other thing we could try, if that's not great for you, you know how we did this up reflect? Let's copy that and I'm gonna paste it down here. And instead of up reflect, let's make it down reflect. I don't know what this needs to be in order for it to be negative. So it could be the absolute value of it so that we know it's positive, and then times -1. Let's see if that works. And I'm going to return the down reflect dot normalized. Oh my gosh, where is it? Okay, trying to spike it now. Yeah. And then shift right click, it goes down. Bam. Perfect. Okay, shift right click is spike. Awesome. Okay, so we have 3 different ways that we can interact with our volleyball. We can spike it, we can tap it up, we can play Keepy Uppy forever. Let's adjust this get power method because we have infinite reach, and let's make it so that we are more powerful the closer we are to the ball, and the farther we are from the ball, obviously there's less power. So instead of just returning 10, we're going to return a different kind of number. So let's say float, our ideal distance would be like 5, right? Like we want to be around 5, and we can adjust that, but like 5 units away from the ball. And then let's say our max power equals 10, right? So now we need to figure out the distance between us and the ball, which is a float value. So float distance is going to equal the vector 3 dot distance between the player dot transform dot position and our transform position. The next part we need to calculate is how far up on the y-axis it goes, right? Like our power upwards. So I'm going to say that's a float. We'll say y for now, and that's going to equal something, some positive value, right? Like some absolute value. So we will once again use mathf dot absolute value of our distance. Now, if you just look up the absolute value of x, this is what you're going to get, is a shape kind of like this. But we almost want the opposite, right? Like the closer we are to the ball, we want it to be up. Like we want to be able to have the most power. The farther we are from the ball, we want lower power. So we almost want the inverse of this, right? So we want to flip that upside down. So let's make that negative. And even if we flip this upside down, so you can imagine the triangle going the other way, the highest point would still be at 0, which is not our ideal distance. Our ideal distance is 5, right? And we want it to be positive. We want it to be the volleyball not behind us, in front of us, that triangle shape of a graph. So we want this to be over 1, right? So we're going to add 1 so that it's into the positives. But because it's flipped upside down, that graph, we want to make sure that so we're pretending that this is 0, and we're going to minus the ideal distance. However far we are from the ball, minus the ideal distance, but then flipped, we'll move that graph over. Naturally, the absolute value of the x graph is a slope of 1, right? Like 1 over 1 down, 1 over 1 down. But if our ideal distance is 5, we want that slope of like that ratio of 1/5. So that it's not a 1-to-1 triangle, the slope is a little bit more gradual, right? So we're gonna take this and we're gonna divide it by our ideal distance, which right now is 5. So I'm gonna do ideal distance. Now that we have these, we can actually calculate our power. So whatever our max power is, let's calculate our float power, and that's gonna equal the y that we just calculated times our max power. And let's make sure to clamp it so it doesn't go way too high. So power, let's clamp it, math f.clamp, and the value we're clamping is power, and it's going to be between 0, so it doesn't go less than 0, and between max power, so it doesn't go above 10. And lastly, instead of returning 10, let's return power. Whoo! Okay, this was a lot, but let's make sure that it's working. I should be able to be about 5 away from it. Okay. And here, I'm just gonna let it go and then see, I can influence it a little bit. I'm gonna back up. I can't influence it at all. Nothing. No clicks, no right clicks, nothing is working until I go closer. And there, now I can click it again. Perfect. Yay! Okay. All right. And that's all working now. So this is your starter project for your volleyball game. There we go. I'm very bad at this game. There we go. There's a whole bunch of different kinds of features that you could add on to this, definitely. And hopefully you understand enough about how we're calculating the power, how we're calculating different kind of bounces that you could maybe make more. I feel like this game is so chaotic too. Maybe if there were other elements that were in here that you had to kind of dodge while trying to keep the volleyball on the other side, that would be cool. Even with just the Keepy Uppy feature alone, that one is also a little bit challenging to navigate. So maybe just having different kinds of game modes where there's Keepy Uppy mode, there's opponents mode, there's like crazy dodge the everything mode. But yeah, give yourselves a round of applause. Yay! You made it. This is kind of like volleyball. I hope you enjoyed it. I hope you're better at this game than I am. All right, bye for now.